Students, today we are going to learn about the usage of screw gauge. So first we learn about the principle of screw gauge. When a screw rotates in a nut, the distance moved by the tip of the screw is directly proportional to the number of rotations. Now you see the nut and you see the screw. So when you place the screw in a nut and when you rotate it, the distance moved by the tip of the screw and the number of rotations made by the screw both will be equal. Supposing the number of rotations is equal to 1, the distance travelled by the tip of the screw also will be 1 division. So, both the distance and the number will be proportional to each other. Is it clear? So, when a screw rotates in a nut, the distance moved by the tip of the screw is directly proportional to the number of rotations. Clear? Now, next one is pitch of the screw. Pitch of the screw is actually the distance moved by the tip of the screw for one complete rotation of the head. So the head will rotate. Okay. So with the head means what? The head scale. You learn the circular scale. So when you rotate the circular scale, what happens there? For one complete rotation, the distance moved by the tip of the screw for one complete rotation of the head. Okay, so when it moves one division forward, you can say it will be equal to 1 millimeter. The pitch value will be always equal to 1 millimeter. So what is the pitch of the screw formula? Distance moved by the pitch. Distance moved by the pitch by number of head scale rotations. By number of rotations of the head scale. Clear? So that is the pitch of the screw. Clear for you all? And what will be that value always? It will be always 1 millimeter. The pitch of the screw will be always 1 millimeter. Now there is one more definition for pitch of the screw. Pitch of the screw is also defined as the distance between two consecutive screw threads. Now you see a screw there. You have the grooves cut on it. So distance between that is called as threads. Okay, so the distance between the two threads, that is called as what? It is called as pitch of the screw. It is called as pitch of the screw. So pitch of the screw, you have two definitions. What we learned earlier and now this definition. Clear? Now next one is least count. Now what is least count? The distance moved by the tip of the screw for a rotation of one division on the head scale. The distance moved by the tip of the screw for how much? For a rotation of one division on the head scale. That is called as least count. So now you see the diagram there. So we see there on the hollow cylinder you see a scale, that is pitch scale, and on the circular one is the head scale. So least count is the value of one smallest pitch scale reading. So what is the smallest pitch scale reading there? 1 millimeter. Okay. And total number of head scale divisions, and we already learned there are 100 head scale divisions. So now you see here, yes, you see on this, you see a 0, 95 and all that. So after 95, 96, 97, 98, 99, 100. So 100 point and the 0 division both are same. So you can say there are 100 head scale divisions. So what is the formula? Value of one smallest pitch scale reading by total number of head scale divisions. So least count is 1. That is the smallest pitch scale reading is 1. By number of head scale divisions is 100. So 1 by 100. So what will be your answer? 0.01 millimeter or 0.001 centimeter. So what is the least count for a screw gauge? 0.01 millimeter or 0.001 centimeter. Hope this is clear. Okay. Now we go on to zero error. When the movable stud of the screw and the fixed stud on the frame are brought into contact, that is we learned about screw gauge, anvil. Anvil is the fixed stud and spindle is a movable stud. So when these two studs, when they are when they are brought into contact, that is when they touch each other. See your diagram. If the zero of the head scale coincides with the pitch scale axis, so the pitch scale axis 0, that line, and the head scale 0, if they coincide with each other, there is no zero error. Did you understand? So when they are coinciding with each other, there is no zero error. Okay. Now zero error, it is classified into two. Positive zero error and negative zero error. So what's the classification? Positive zero error and negative zero error. So what is positive zero error? So when the movable stud and the fixed stud, so when the anvil and the spindle, when they are brought into contact, when they touch each other, if the zero of the head scale lies below the pitch scale axis, we saw one line, no? Pitch scale line. So if the zero of the head scale lies below the pitch scale axis, the zero error is positive. The zero error is positive and the correction will be opposite to it. The zero correction is negative. So when the zero error is positive, the zero error correction will be negative. Clear? Now how will you calculate? Just see the diagram. After 0, so where is 0 lying? 0 is lying below the pitch scale axis. Now which division is coinciding after 0? 1, 2. Second division of the head scale coincides with the pitch scale axis. Clear? So which division is coinciding? Second division. So to find out the zero error, your formula will be zero error is equal to plus n into LC. N denotes the division. So n into LC. So now which division is coinciding? Second division. So plus 2 into 0.01. So when you multiply, you get plus 0.02 millimeter. You will get plus 0.02 millimeter. So your zero error is positive and your value is plus 0.02 millimeter. So your correction will be just opposite. Zero correction is minus 0.02 millimeter. Did you understand? Okay. Now negative zero error. When the movable stud of the screw and the fixed stud, so when the movable stud and the fixed stud, when they are brought into contact, when they touch each other, if the zero of the head scale lies above the pitch scale axis, the zero of the head scale, where does it lie? Above the pitch scale axis, the zero error is negative. The zero error is negative and the zero correction will be positive, just opposite. Okay, so zero error is negative and the zero correction is positive when with the zero error of the head scale lies above the pitch scale axis. Clear? Now see the diagram. So now which division is coinciding? Okay, so after 95, 96. So here the 96th division is coinciding with the pitch scale axis. So the zero error formula for this is minus of 100 minus n into LC. Minus of 100 minus n into LC. What is n here? 96. So you write minus of 100 minus 96 into 0.01. So what is 100 minus 96? 4. So minus 4 into 0.01, that is equal to minus 0.04 millimeter. So your zero error is negative. So what answer did you get here? Minus 0.04 millimeter. So what will be the correction? Positive. So the zero correction is plus 0.04 millimeter. So what is the zero correction? Plus 0.04 millimeter. Hope you have understood how to use a screw gauge. The principle, pitch of the screw, least count, zero error, positive error, negative error. So did you understand all this topic? Okay. So learn this, just go through it, learn it well. Thank you.